Hey there, so I wanted to make a very quick video explaining how to use the process of cross-canceling whenever you're multiplying fractions. So what we're going to do is we're going to look at the numerator of one fraction and the denominator of the other fraction. And one way to remember that it's called cross-canceling is because we're literally looking from one across to the other. So looking at the numerator here and the denominator here, I need to ask myself, is there any factor greater than 1 that can go both into 7 and 5? Well, no. 1 would be the only common factor they share. So let's look at the other denominator compared to the numerator across the way. So we've got 10 here and 2 here. So I'm going to ask myself again, is there a number greater than 1 that can go into both 10 and 2? Well, first off, I know they're both even numbers. So the factor that can go into any even number would be 2. So I'm going to divide by 2 up here, and I'm also going to divide by 2 down here. Okay, you have to divide by the same number. So dividing by 2, I'm going to put this little sign so I don't forget, and then I'm also going to put dividing by 2 here. So let's go ahead and do that, and then we'll cross out our numbers. So I've got 2 divided by 2. That's going to give me 1. I'm going to mark out the 2 and I'm going to circle the 1 because that's now the new number I'm using. And I've also got to do it down here as well since I am cross canceling. So I'm going to go across and I'm going to divide by 2 on the opposite denominator. So 10 divided by 2, I'm going to mark that out. And now I get the number 5. So I'm going to circle that. That's going to be the new denominator that I use here. Now after I've cross-canceled both, I'm going to go across the top multiplying and then across the bottom multiplying to get my answer. So we have 7 times the new number 1, which gives me 7 as the numerator. And then I've got the number 5 times 5, and that's going to give me 25. All right, so this is already in simplest form because there's no factor greater than 1 that can go both into 7 and 25. So this would be my answer. So as you can tell, the cross-canceling definitely helped us because it gave us the simplest form whenever we multiplied. All right, let's go ahead and look here. Once again, looking at the numerators of one fraction and the denominator of the other fraction. So we can go across and see what we can cancel. So I see the 4 in this numerator and the 2 in this denominator. So I can ask myself, what factor greater than 1 can go both into 2 and 4 evenly? Once again, they're both even numbers, so I can simply divide by 2 and divide by 2. What I'm going to do is go ahead and do this one first. 2 divided by 2 gives me 1. Marking out that number, circling the number 1 because that's the new number I'm using. Now 4 divided by 2, that's going to cross out and give me 2. I'm going to circle it, so I use this number instead. Now I'm going to look to see if I can cross-cancel the other numbers in my problem. I've got 5 in this denominator. I'm going to go across and look at the numerator in the opposite fraction. So I've got 5 and 1. So is there a number greater than 1 that can go both into 1 and 5 evenly? No, so I'm just going to have to leave those numbers the same. So now I'm going to multiply across the top to get my new numerator and then multiply across the bottom to get the new denominator. 2 times 1 is going to give me 2. And then 5 times 1 is going to give me 5. So once again, I'm going to just triple check, making sure that this is in simplest form. I've got 2 in the numerator, 5 in the denominator. Is there a factor that's greater than 1 that can go both into 2 and 5 evenly? The answer is no, it is in simplest form, so I'm going to circle that as my answer. Okay, so I hope this really helped to review cross-canceling. Remember, you're looking at the numerator of one fraction, and you're going across and looking at the denominator of the other fraction, and you have to see if there's a common factor that can go into both. So remember, if you choose a factor, it has to divide into the denominator evenly and into the opposite numerator evenly. So I use 2 for both of these when dividing, and I use 2 for both of these when dividing as well. So I'm using that same number when dividing. All right, thank you so much. Have a great day. Bye-bye.